In this video, we're going to be solving logarithmic equations. So we'll just dive in. We start with this logarithmic equation of log base 5 of x equals 3 times log base 5 of 4. Notice that I have a logarithm on each side of the equation. Everything is either in a logarithm or multiplied times 1. Notice that on our properties sheet, we do have property h, which says log base b of m equals log base b of n if and only if m equals n, which means this equation can only be true if these two inputs are equal. However, that's not exactly what we have here, because we have this 3 that's sort of complicating matters. The m and the n are the inputs of the log, and neither one of these have anything multiplied in front. However, I can use property g from this list to pull this 3 inside, and so I've got log base 5 of x is equal to log base 5 of 4 cubed. Now 4 cubed is 64. So I've got log base 5 of x equals log base 5 of 64. Now I have a logarithm on each side with the same base, and I can conclude from that that my inputs have to be equal. X is equal to 64. And there's our solution. One thing that we will be pointing out over and over again is that logarithms have restrictions on what can be used as inputs. The domain of any logarithmic function is the set of all positive numbers. We mentioned that in our first logarithm video, and it's also up here at the top of under your logarithms basic facts. 64 is a positive number here, so the fact that x is 64 is perfectly okay. However, we are going to want to be cautious when we might be creating negative or 0 inputs for logarithms, because those are not allowed. So let's look at this one. Notice this one is significantly different from number 1. On number 1, I had 2 logarithms and I had something that I could rearrange into a single logarithm on each side. Here I've got 1 logarithm, and I'm always going to have a logarithm and a number. That means that I won't be able to use property h the way that I did for number 1. However, if we go back to the logarithms reading, and under these basic facts, remember that the logarithm is y equals log base b of x is equivalent to x equals b to the y. So I can rewrite my expression that is in log form in exponential form, and that will frequently be helpful. Notice right now I don't have exactly something I can rewrite into rewrite into exponential form, because this 2 is complicating matters. Now, one thing that I could do is pull that inside to become x squared. That is allowable. However, I can also divide both sides of this equation by 2, and that's going to be sort of a simpler process. If I divide both sides of my equation by 2, I get log base 5 of x equals 6 divided by 2 is 3. So now I've got a slightly simpler equation in logarithmic form that can be written in exponential form. So x is the input of the logarithm, and in exponential form, that's what goes on one side by itself, the input of the logarithm. The base of my logarithm is 5, and my thing that's equal to my logarithm is 3. So x is equal to 5 cubed. Of course, 5 cubed is 5 times 5 times 5, which is 125. Again, I have a positive value for x, which, since x is the input of a log, that's a good thing, since the inputs of logs cannot be negative. Now, let's look at some more. So I've got, in my next one here, log base 2 of 2x plus log base 2 of x is equal to 5. I can combine these two. I get log base 2 of 2x times x, because I'm multiplying my inputs together, and 2x times x is 2x squared, and that is equal to 5. So now I can rewrite that in exponential form. The input of the log is equal to the base of the log to the power of 5. So now I have 2x squared equals 2 to the 5, which is 32. I'm going to continue my process over here so I don't interfere with the problem below it. And 2x squared equals 32, which means x squared is equal to 16, which means x is equal to plus or minus 4. Now here we do need to be careful. I have two separate answers, positive 4 and negative 4. But a negative 4, well, if negative 4 is my x, then that would make the input of this logarithm negative 8, which I cannot have the input of a logarithm be negative. So negative 4 cannot be a solution, since it would make the input of a log negative. Of course, I'm writing that out just as a note. If you were just working this problem as a homework problem or on the test, you wouldn't need to write that note. You just need to know that. And so the only solution is x equals 4. So now let's go on to number 4 here, which I already have everything. I don't need to combine logarithms or anything. I can write this in exponential form as x plus 2 is equal to 3 to the 0. Of course, 3 to the 0 is 1. I get x plus 2 is equal to 1. And so x is equal to negative 1. So my x is negative, which at first, when working logarithm problems, people might be tempted to throw that away. But remember, it's not x that can't be negative. It's the input of the entire log that can't be negative. Now, the input of this logarithm is x plus 2. If I have negative 1 as my x plus 2 is positive 1, which is a positive number and so is an allowable input for the log. So we do get to keep our solution of negative 1. Let's make a note of that, even though negative 1 is negative. the input of the log is x plus 2, which is negative 1 plus 2, which is positive 1, which is positive. This means our solution is good. So we do get to keep that solution. We don't have to declare it as an invalid input to this problem. All right, we have 2 more problems, so let's move on to the next one. So, log base 6 of k plus 5 over log base 6 of k minus 5 is equal to 1. So the first thing that I'm going to do is combine these into a single log. So I'll get log base 6 of k plus 5 over k minus 5 is equal to 1. Now I'm going to rewrite it in exponential form. So k plus 5 over k minus 5 is equal to 6 to the 1. Of course, 6 to the 1 is just 6. So if you wanted to rewrite that, now I need to get this k out of the denominator. So I can multiply both sides of this by k minus 5. So if I multiply both sides by k minus 5, on this side that will cancel out and leave me with just k plus 5. On this side I can distribute my 6 and get 6k minus 30. So now I can subtract k from both sides. That way I'll get 5k over here. I can also add 30 to both sides. I'll have 35 over here. Now divide both sides by 5. And so I get k equals 7. Now even though I got a positive number as my result, since my inputs for my logarithms have stuff going on, I do need to check. So 7 plus 5 is positive. 7 minus 5 is also positive. Now, if this had been a k minus 10 or something, then 7 minus 10 would be negative. And in that case, I would have to throw this away even though 7 is a positive number. But this is perfectly good for the inputs that this problem has. So that is our solution to number 5. And now, number 6. Notice that every single thing is either part of the input to or multiplied by a logarithm. So the process for number 6 is going to be more similar to the process for number 1. I'm going to get it down to a single log on each side of the equation, and then I'm going to use property h on our logarithm properties list and say that if 2 logs with the same base are equal, then the inputs have to be equal. So my left-hand side is as simple as it gets, that log base b of x. So I'm just going to recopy that. I can pull each of these numbers in. So when I say pull them in, they become the exponent of the input. So 27 to the 2/3 plus log base b of 2 squared minus log base b of 3. So now I need to think about this 27 to the 2/3. If you have a decent scientific calculator, that should be able to calculate that for you. But remember, fractional exponents are roots. So this is, I'm taking the cube root, since it's a 3 that's in the denominator. It tells me what root I'm taking. And then I'm going to be squaring that. So the cube root of 27 is 9. And then, I'm sorry, I was thinking ahead. The cube root of 27 is actually 3, and then when I square that, I get 9. And again, you can punch that into a calculator and have the calculator do the calculation for you if you like. So log base b of 9 plus 2 squared is 4. So this is log base b of 4 minus log base b of 3. So now I'm going to start combining these. I have addition between these two logs, which means I can write that as a single logarithm with multiplication in the input. 9 times 4 is 36. And then I need to keep this minus log base b of 3. And now finally, I've got subtraction between these two logs. And subtraction between two logs can be written as division in the input of a single log. So it's log base b of 36 divided by 3. And of course, 36 divided by 3 is 12. Now I have log base b of x equals log base b of 12. And notice I never even knew what the base was for this logarithm. It was a variable all along, but it actually doesn't matter as long as it's the same. And notice it was the same for everything. That's what allowed me to combine these logarithms into a single one. And it's the same on both sides. So that means I can say that the inputs have to be equal. And x equals 12. And of course, 12 is a positive number, and since I wasn't doing anything else to x for the input of this logarithm, I know that I have a good solution with 12. And that is our video on solving logarithmic equations.